The Sustainability Impact Award 2026, an initiative of Misset International, recognizes and promotes innovative, sustainable solutions within the animal feed sector. Nottingham Trent University has been nominated for this award. Corn fermented protein recovers high-protein ingredients from cereal bioethanol co-products, reducing reliance on imported soy and cutting carbon emissions.
Hi Emily, what challenges in the animal feed production led to the development of this circular protein solution?
Well, two things really led to this development. So across Europe, we are short of protein that's produced within Europe. We're really reliant on importing soya. And we have a second problem, which is we're under enormous pressure to reduce the carbon footprint associated with livestock production. And those two challenges sit really heavy on the sector. And there's a third sector that I always look at. I'm quite a systems thinker, and I've never liked the reliance on imports. I've always found actually Europe is such a small player globally. We've got no control over price, no control over markets. So I always felt that we were vulnerable. And at the moment, with the geopolitical crisis that's going on, actually over fuel itself, it's demonstrated that food and energy security for Europe are absolutely crucial, not relying on imports. So that, and the current situation with the EU Commissioner, she's actually just stated that she would like bioethanol production to go up 4 times. And I think that's a result of the Hormuz crisis, but it's very timely. It's an obvious solution. We had it ready, and I just feel glad that it's ready to roll out.
And how does Nottingham Trent University contribute to the development and validation of this solution?
Well, the way it started, it was a really long time ago actually. It was nearly 15 years ago that bioethanol production, it came to the UK and it was growing in Europe. And my specialism is optimizing feed materials in a way to lower the carbon cost of feed production. And I thought, if dry distillers grains are coming, we must do something with them. And when I spoke to Pete about it, he said, we need to do far more than that, Emily. We need to redesign. And he was really quite advanced in his thinking. So he'd identified with really big picture thinking that we simply needed to separate out protein, fibre and yeast, and that bundling them together was completely inappropriate, sort of accidental production process. The role of Nottingham Trent was to look biologically and environmentally at what happened to the product and how you optimize it. So while Pete and I came together to work on this, at the same time, a group of engineers in the US, they were grappling with how to take the dry grind bioethanol process and produce a product of the same quality that the wet grind process. So wet grind bioethanol makes corn gluten meal. It's a beautiful product, but in quite a small system. And so they, sort of in parallel to us, they were looking at how you could mechanically separate. And Pete's very good at looking really broadly, and he approached them and began working with them. And then we all three kind of thought processes all came together. So, and there were other people working in this concept as well, but for us it was a bit of a magical collaboration really in getting to where we are now. I think the bottom line of our contribution is that we've enabled other people to commercially exploit this wonderfully sustainable innovation and helped all the stakeholders to recognise its value by helping to measure things. We measured the phosphorus availability, we measured the gut health, we measured the amino acid digestibility. So I'm not claiming that we brought it to market, but I feel really proud of how we enabled others to take it into the marketplace, which they've done brilliantly.
Can you explain how your circular protein is produced?
So our process starts off the same as traditional processes. So you take some ground up cereal, and just like making beer, you put it through a fermentation process, and then you distill it and you draw off the ethanol for that. And the innovation comes in the next bit. So traditionally, we've taken everything that's left over, so the watery, fibrous residues, and they're dried and make distillers grains. So this is where we completely change the process. So instead of making a sort of nutrient bundle that pushes the fibre and the protein together, so we've got a product there that's kind of perfect for no one. There's protein in there that's too valuable for the cow sector, but there's too much fibre for non-ruminant animals. So we split them and never rejoin them, and we needed to make a product that hit all those needs of the sector, available in really high volumes, available all the year round, the right price. So for me, it's a perfect trinity of those needs. The crucial thing about this new protein is it doesn't come from new agronomy or trying to produce a new plant crop for Europe, and it doesn't come from needing new land. The special part about this is it addresses the feed fuel debate that's associated with bioethanol production, and that's really why Europe have been unkeen to adopt and promote bioethanol. But from one piece of land, you're now getting sustainable fuel and you're getting protein. The reduction in carbon footprint from this product, it comes from being able to split the carbon footprint across the bioethanol and across the food product. So suddenly from one piece of land mass, you've split the carbon allocation across them both.
So what impact is this solution already having on the animal feed industry, and how do you see it shaping the future?
This is the first new viable protein source that's come to the feed sector for 20 years. And it doesn't just solve the feed challenges of protein, it simultaneously solves the feed versus fuel debate. So at a systems level, it's more than solving a feed problem, it's solving a renewable fuel problem at the same time.
So when is it available?
It's actually available now. So in the US, there's enormous amounts already being made and going into many different livestock, aqua and the pet sector. And in Europe, we're ready to produce 100,000 tonnes of it.